One kind of simple machine is not as easy to notice as the others, but it makes work easier just as all simple machines do. You use it every time you cut something, or turn a screw, or push something uphill. The simple machine is the tilted or inclined plane, in this case, the slope of the hill itself. When you push something up a slope, you're using an inclined plane to help you lift. The inclined plane works as a machine even though it doesn't move. Suppose you want to raise a weight or load, a fairly heavy one. It might be difficult to lift it straight up. You'd have to supply the entire lifting force yourself. But if you push the load up a steep inclined plane, the job is a little easier. You can apply less force, because now the inclined plane applies some force to help you. It bears some of the weight. If the inclined plane is flatter, pushing is still easier. You don't need to apply much force, because the inclined plane applies a lot of force. It bears most of the weight. And you know it's easy to push something along a surface that's almost flat. The inclined plane supplies a very large force to support almost all the load, and you need to apply very little force. However, force isn't the only thing that changes each time you change the slope of the inclined plane. Suppose you want to raise a load from this level up to here. If you lift the load straight up, you only have to exert your force this distance. With this slope, you need to exert your force a little farther, this distance, in order to raise the load to the same height. How about this slope? Now you exert your force through a greater distance. And with this slope, you exert your force still farther, each time to raise the load to the same height. So the flatter the slope, the more distance you need to move your force, but the more force the inclined plane applies. You trade distance to get force to help you lift things. When people think about building an inclined plane, they choose a slope that will give the best combination of force and distance. For instance, ramps for people to walk up are usually about this slope, not too long and not uncomfortably steep. But how does this slope work when you want to get up high, like to the top of a big stadium? Most stadium ramps don't look like this. That's because they're more compact. Often they're folded. People who make mountain roads also have to make them compact. This road is too steep for cars. This is a better slope, but it takes a lot of supports to hold it up. Here's an easy way to keep the same slope. Make it a winding road. Cars have to travel a long way to get up the mountain, but they can do it without using too much force. Besides folding or bending an inclined plane, there's another way to make it compact, and that is to wrap it around something. These are all inclined planes that hold still while people or things move over them. But if we make an inclined plane smaller, we can move it instead. At the end of this chisel, for instance, is a small inclined plane. The hammer exerts a force to drive the chisel along, and the chisel exerts a force to spread the rock apart. Notice that the direction of force changes from this direction to this. But a chisel only pushes in one direction at a time. Suppose instead you had two inclined planes back to back. You'd have a wedge. If you apply a force to a wedge in this direction, it applies a force both this direction and this direction to spread something apart. Wedges can be made with any slope, depending on the job that needs to be done. If you want to cut through something hard, like wood, you need a wedge that's fairly flat. You can see how the forces work if you think of just one of the inclined planes. Your force moves a large distance. That's the distance the axe enters the wood. While the inclined plane applies a large force here. The other inclined plane applies an equal force this way, and together they push the wood apart. But you often use flatter wedges than this. For instance, when you use a knife. The wedge is the whole cutting edge. When you cut into an apple, this wedge travels a very great distance compared with the distance it pushes the apple apart. So the amount of force you put in here is very greatly multiplied here. The flatter the cutting edge is, the greater these forces will be, and the more easily the knife will cut. Now, suppose you take a fairly flat slope and wrap it around a central core, like the ramp we saw earlier. This gives you a very useful tool, a long inclined plane in a very compact form, screw threads. Here they're on a bolt. The threads are one inclined plane. This is a nut. It has a matching inclined plane here on the inside. When you turn the bolt, the inclined plane on it slides over the inclined plane in the nut. It's just as if you took two straight inclined planes and moved one over the other. When you move this inclined plane sideways or horizontally, it also goes up or down. Coiled inclined planes work the same way. You apply a force horizontally to turn the bolt, and the inclined plane applies a force to raise or lower the bolt, depending on which way you turn. Since this inclined plane is quite flat, the force it applies is quite a lot greater than the force you apply to turn the bolt. What happens if the slope is even flatter? The threads are closer together now. And when you apply your force to turn this bolt, it moves with an even larger force. You can use this force, for instance, to raise a heavy load, or to squeeze something. But as you know, force isn't the only thing that changes when you change the slope. To raise this bolt this far, you turn it only a few times. Your force moves this distance. But to raise this bolt with the flatter slope, you turn more times, more distance. So once again, the flatter the inclined plane, the greater distance you move your force, and the greater the force the inclined plane exerts. Bolts aren't the only tools with threads. Screws are threaded too. But most screws are tapered, so in addition, they work as wedges. A nail uses a wedge, but that's the only inclined plane it uses. To drive a nail, you have to apply a lot of force by hitting it hard. You apply the force over this distance. You don't need to apply as much force to a screw because you apply it over a greater distance. But in a screw, there's also another way inclined planes are used. If you look closely at the threads, you can see that they're really wedges. As the screw turns, they push out into the wood. And because of them, the screw is held very firmly in place. It isn't too hard to pull out a nail, but it takes a tremendous force to pull out a screw. So we've looked at many kinds of machines that make work easier in different ways. But they all multiply force in exchange for distance by using inclined planes.